everyone, welcome to Get Academy Global. So today we are going to discuss the workbook questions. So tell me, all of you tell me whether you are having the workbook questions or not. All of you having workbook questions with you? Hello Satish, hello Sakshi. Hello Hemant, good evening, Rishika, Lakshmi. So tell me once, all of you having workbook questions with you or not? Okay. So Ashok is saying that he is having the workbook. And what about others? What about others? Yes, having the PDF, very good. And what else? What about other students? Yes, Rishika, good. So if you all are having the workbook question, then there is no need of writing the question on the board. So Sakshi is saying that she is not having the question. So Sakshi, are you in the Telegram group? Sakshi, are you in the Telegram group? So out of this, yes, Sakshi, if you are in the Telegram group, then you can download the PDF from there. Okay. Good evening, Anju. So Anju, you are having that PDF of the workbook. So Lakshmi and Ashish, if you guys are having the PDF, then share it in the Telegram group right now, so that Sakshi can download, and she will be having the workbook question. Then we will be solving the questions now. Okay, so once share the PDF in the Telegram group, because my net is not working here, so I will not be able to share. So I request you all to share the PDF in the Telegram group. Okay, share the PDF in the Telegram group so that the Sakshi and Anju will download, and once they download, they will also be having the questions. So we will solve the questions. So Sakshi, did you get this PDF? Sakshi and Anju, did you get this PDF? Yes, Anju, it is in Telegram. You can download it from the Telegram. As Sakshi has got the PDF from the Telegram, you just go to the Telegram group and you can download the PDF from there. Okay, Anju, so I am waiting for your reply. Once you get the PDF, so all 8 students, those who are attending the session right now, should have that PDF, because if out of 8, if anyone is not having, then it will not be good to start the questions, because we are only having 8 students right now with us. So if all the 8 students will not be solving the question, then there is no need to continue the session right now. So I am waiting for the Anju to get the PDF of the workbook, and after that we will solve the question. Okay, so let's start with the first question. Okay, so let's start with the first question of the workbook. In this question, it is given that a medium has mu r is equal to 1 and epsilon r is equal to 25. The phase velocity of the medium is. Okay, so mu r is equal to 1 and epsilon r is equal to 25. You have to calculate the phase velocity. Okay, so solve this question. Thank you, Lakshmi. Mu r is 1, epsilon r is 25. Solve this question. Yes, Ashutosh, it is live session. It is live session going on. You have to solve this question. So the question is, you are having a medium in which the wave is traveling, in which mu r is 1 and epsilon r is 25, the phase velocity is. So the phase velocity, because it is given as epsilon r and mu r only, it is not saying about anything about the alpha, and there is no information to get the value of alpha. We will consider it as a lossless dielectric, and lossless dielectric is having the velocity Vp is equal to c upon root over epsilon r. So this is 3 into 10 to the power 8 divided by root over 25. So this is 0.6 into 10 to the power 8 meter per second. So this is the first question. Just to recall the formula. Okay, just to recall the formula. Now we are having the second question. Okay, let's solve second question. The second question is, if wet soil has sigma is equal to 10 to the power minus 2 mho per meter and epsilon r is equal to 15 and f is equal to 60 hertz. It is a good conductor, good dielectric, semiconductor or magnetic medium. Good evening, Subhashri. Okay, you have to tell which kind of medium is this, whether it is a good conductor, good dielectric or semiconductor or magnetic medium. ठीक है, so I want everyone to solve. So all the 15 students, those who are live, should solve the question. So you guys are getting good dielectric, okay, Hemant? Okay, conductor she is getting, Anju. So to decide which kind of medium is this, we have to calculate the sigma upon omega epsilon, and the value of sigma is 10 raised to power minus 2 whole divided by omega, that is 2 pi, frequency is 60, and epsilon is your 15 into epsilon naught, which is 10 raised to power minus 9 divided by 36 pi. So when we solve this, what we get, how much it is coming, because I have got the two different answers like good dielectric and good conductor both. So let me solve this. So as I can see that it is approximately 20,000. It is 20,000, or in fact 200,000. In fact, it is 200 into 10 raised to power 3. Yes, Rishika. So as you all can see that here this sigma upon omega epsilon is very greater than 1. Hence we will write the sigma is very greater than omega epsilon. So if this condition is satisfied, we call it as a good conductor. We call it as good conductor. Thank you, Lakshmi. Okay, so we have solved the two questions and both are just a basic questions, and all the questions that we will solve today will be having the just a recall of formula and how to apply these questions in the exam. Okay, so both these questions are from the GATE exam only. This type of question has been previously asked in the GATE, so it can be asked in the future also. So now let's solve question number 3. Question number 3. A manufacturer produces a ferrite material with mu equal to 750 mu naught and epsilon is equal to 5 epsilon naught and sigma is equal to 10 raised to power minus 6 Siemens per meter at 10 megahertz. The intrinsic impedance is. Okay, so in this question it is given that mu is equal to 750 mu naught and epsilon is equal to 5 epsilon naught and sigma is equal to 10 to the power minus 6 Siemens per meter. Now we have to calculate at 10 megahertz. So the frequency is 10 megahertz. Now we have to calculate intrinsic impedance. Intrinsic impedance we have to calculate. Okay. Good evening, Pankaj. So first calculate this sigma upon omega epsilon. Calculate this sigma upon omega epsilon. Sigma upon omega epsilon, which is 10 to the power minus 6. This is 2 pi into 10 into 10 to the power 6 into 5 into epsilon naught, which is 10 raised to power minus 9 divided by 36 pi. So let's calculate this first and then we will see how to solve this. 5.6k you are getting. Okay, so Gaurav, you have to check your answer. Yes, Anju, 3.6 into 10 raised to power minus 4 we are getting. So 3.6 into 10 raised to power minus 4. So now I am going to tell you one more thing about in this question which I have not discussed it previously. So see, whenever the sigma upon omega epsilon is less than 0.01, whenever sigma upon omega epsilon is less than 0.01, it is considered as a low loss medium. Okay, and when it is a low loss medium, the value of alpha is given by sigma by 2 root over mu by epsilon, and the value of beta is omega root over mu epsilon, and value of eta is root over mu by epsilon, and the value of Vp is 1 upon root over mu epsilon. Okay, so remember this, another medium, you can say, another medium, because we have discussed the 4 medium. It is a kind of lossy medium itself, but it will reduce the calculation because you have reduced the formula of alpha and beta, because here we can see that this sigma is very less than 1. So to calculate the value of eta, we will apply the big formula that we have discussed. But that what formula we have discussed? So the formula which we have discussed is root over mu by epsilon and divided by 1 plus sigma upon omega epsilon whole square and whole to the power 1 by 4. But what I said is, if the sigma upon omega epsilon is less than 0.01, it is considered as low loss medium, and when it is considered as low loss medium, you can calculate the alpha beta by this formula, and eta is directly root over mu by epsilon, which is very much similar to the lossless medium. Okay, which is very much similar to the lossless medium, because this term is very small. If you square this term, it is very small. It becomes more small, because when you square it, it becomes 10 to the power minus 8. So in compare with 1, 10 to the power minus 8 is very small value. So we can neglect this term, and once you neglect this term, you will get the root over mu by epsilon, which is the value of eta. So here you will get 120 pi and root over mu r divided by epsilon r, because this term is neglected. Okay, so we have neglected this term, and or you can say that we are using this formula directly, and from here you will get 120 pi root over mu r is 750 and epsilon r is 5. So after solving this, you will get, I think 3.6 or 4.6. What you are getting? Yes, 4.6, Gaurav. 4.6 it is. So 4.6 kilo ohm. Okay, that is why there is no angle given in the option, because for this particular case, the imaginary part that we consider is actually 0. So instead of using this formula, you can use directly this formula and get the answer. So you don't need to apply the value of alpha, that is omega root over mu epsilon by 2 in bracket 1 plus sigma upon omega epsilon whole square minus 1, and for beta it is plus 1. So no need to apply that formula once you get the sigma by omega epsilon less than 0.01. If it is greater than 0.01, then you will get the appropriate answer when you apply the general formula. Okay, is it clear? Next is question number 4. So in question number 4, it is given that the electric field E is equal to 5AX plus J10AY e to the power minus j 2Z volt per meter. A uniform plane wave has electric field at 50 megahertz in a lossless dielectric medium. Then calculate the intrinsic impedance. Okay, so it is at 50 megahertz. You have to calculate the value of eta for a lossless medium. The medium is lossless. Okay, calculate intrinsic impedance. So in this question, as you can see that whenever the electric field is given, the electric field is given in the form of E naught, and this is cos of omega t minus beta z ae cap, or in the form of E naught e to the power j minus j beta z and e to the power j omega t ae cap. Okay, so in this form it is given. So you can see that because the j is associated, this is related with the phase. So when you compare this term with this given term, you will find that the beta is equal to 2. So the beta is equal to 2 radian per meter. Now you have to calculate the value of eta. The value of eta is 120 pi root over mu r divided by epsilon r, and since there is no information about the mu r, we will take non-magnetic medium, because most of the practical dielectrics are lossless dielectrics are non-magnetic in nature. Now what is the value of mu r? Because we don't have the value of root over mu r, so what we have to do is, so we know the formula for beta. What is the beta? So beta is omega by c root over epsilon r for lossless. This is for lossless medium. We know that the beta is omega by c root over epsilon r, and the beta is 2. Omega is 2 pi into 50, and this c is 3 into 10 to the power 8 and root over epsilon r. Okay, so this is this 2 and 50 become 100, and this 10 to the power 8 will get cancelled, and we get, one second, this is 50 megahertz. Okay, so this will become 10 to the power 6, and this is 10 to the power 6. Actually it is megahertz. Okay, it's because the permittivity, relative permittivity was going in the 10 to the power 6, so it is not possible, right? So 50 into 200, and this 100 will cancel this 10 to the power 8 and will become 10 to the power 6, and this 10 to the power 6 and 10 to the power 6 will also cancel, and this root over epsilon r is 6 upon pi. So root over epsilon r is 6 upon pi, and now we will substitute this value here, and this is 120 pi divided by 6 upon pi. So this eta will be 120 pi square upon 6, and this is 20 into pi square. So 20 into pi square, the pi square means 3.14 whole square, so it is approximately 10. If it is approximately 10, so it is approximately equal to 200 ohm, and the option near to the 200 ohm is 198. So the correct answer would be option C. The correct answer would be option C. Yes, Gaurav, 198 or approximately 200, because there is no option which is near to this 200, so we can definitely say that 190 ohm would be the answer. Zero 0.526. What is that 0.526, Anju? Okay, so don't do this type of mistake. Okay, so next solve question number 5. Question number 5 is, a uniform plane wave is specified by h is equal to 2 into, a uniform plane wave is specified by h is equal to 2 into e to the power minus j 0.1 z into ay. If the velocity of the wave is 2 into 10 to the power 8, if the velocity of the wave is 2 into 10 to the power 8, that means it should be the phase velocity, okay, because we are talking about some medium. If it is air, then it is 3 into 10 to the power 8. And relative permeability, that means mu r. So relative permeability is given as 1.6. The operating frequency in megahertz we have to calculate. We have to calculate this operating frequency. Okay, so can you calculate it? So now, if we want to calculate this frequency, as we can see that this Vp is given, so this Vp is nothing but C upon root over mu r into epsilon r. So this Vp is 2 into 10 to the power 8, and it is 3 into 10 to the power 8 divided by root over mu r, that means root over 1.6, and root over epsilon r. So from here we can calculate the value of root over epsilon r. So which is 3 into 10 raised to power 8 and 2 into 10 raised to power 8 into root over 1.6. So we will get some value. So this is 1.5 divided by root over 1.6. It is 1.18. 1.18 we are getting. So this is the root over epsilon r. Now next if I calculate the frequency, so because the another value which we are having is beta, because on comparing we will get the beta 0.1, which is again omega by c root over mu r into epsilon r. So this beta is 0.1 equal to omega, that means 2 pi f divided by 3 into 10 to the power 8 and root over mu r into epsilon r. From here we can calculate actually root over mu r by epsilon r, which is from here if we calculate directly, okay, so there is no need of calculation of this. So root over mu r by epsilon r, if you calculate directly mu r and epsilon r, so this is c upon vp and 3 into 10 raised to power 8 divided by 2 into 10 raised to power 8. So we will get 1.5 directly. So there is no need of calculating this, and we can write directly 1.5, and this 1.5 into 2 become 3. So this 3 and 3 will also get cancelled, and we will get 0.1 into 10 to the power 8 divided by pi, because this 3 and this 2 and this 1.5 will get cancelled. 0.314, yes. Three point one eight, yes. 3.18 megahertz. So in this question we solved for the root over epsilon r also. So when you square it, you can also calculate the relative permittivity. Okay. So if you want to find the relative permittivity, then also you can calculate in this question, which is your 1.39. If you calculate it further, this is epsilon r is equal to 1.39. Okay, if we want to calculate it, root over epsilon r 1.39. Is it clear? Is it clear up to this point, up to question number 5? Okay, so yes, Hemant, you can calculate this also. Okay, because this Vp is equal to omega by beta. We also know this formula, so we can directly use that. Vp is equal to 2 pi f into beta, and f is equal to Vp into beta divided by 2 pi, and Vp is equal to 2 into 10 raised to power 8, and beta is equal to 0.1, and this is 2 pi. So when you solve this, you will get the same expression which we have got here also. Okay, that is the same expression, 0.1 into 10 raised to power 8 upon pi, 0.1 into 10 raised to power 8 upon pi. So this formula you can also use. If permeability not given, then we take it as 1. Why not in the case of permittivity? As I told Anju that the lossless dielectric mediums are non-magnetic in nature. So the permittivity cannot be 1, but the permeability equal to 1 denotes the medium is non-magnetic in nature. So if any medium is non-magnetic, then mu r is 1. But that is not the case of the permittivity. That is why we by default take the mu r equal to 1 if it is not given, and if the sufficient information is not given to calculate the value of mu r. Yes, Gaurav, correct. Okay, now tell me, can you solve question number 6? Can you solve question number 6? So question number 6 is, for a uniform plane wave of frequency 10 to the power 6 hertz propagating in a good conductor, the field undergoes a change in phase by 2 pi radian over a distance of 1 meter. When the wave is traveling in the good conductor, the field undergoes a change in phase of 2 pi. So change in phase by 2 pi over a distance of 1 meter. The field is attenuated by a factor of 1 by E at a distance of. At which distance the field will be attenuated by 1 by E. So what it is asking? Field is attenuated by factor 1 by E, means we have to calculate skin depth, isn't it? We have to calculate the skin depth, isn't it? Is it correct or not? Is it correct or not? Skin depth. Good evening, Girish. So we have to find the skin depth, and as we said that the phase is changed by 2 pi of traveling a distance of 1 meter. So what is the meaning? What the phase constant denotes? Phase shift per unit distance. Okay, so the phase constant is defined as phase shift per unit distance. So phase shift per unit distance, so that is beta, and how much is phase shift? 2 pi over a distance of what? 1 meter. So we will get 2 pi radian per meter. And now it is given as good conductor. So in good conductor alpha is equal to beta, and that is equal to what? 2 pi. And skin depth is given by, what is the skin depth? The skin depth is nothing but the inverse of attenuation constant. So the attenuation constant is 2 pi. So skin depth will be 1 upon 2 pi. Yes, Rishika? Is it 2 pi or 1 upon 2 pi? Very good. 1 upon alpha. Very nice. Now let's solve a common data question, that is question number 7 to 10. Okay, let's solve one question which is a common data question. Now question number 7 to 10, this is a common data question. A lossy dielectric has intrinsic impedance. So the intrinsic impedance as given as 200 at an angle 30 degree at a particular radian frequency. The plane wave propagate through the dielectric has magnetic field component. So the magnetic field component is given, which is 10 into e to the power minus alpha into x cos of omega t minus 1 by 2 into x ay cap. So now you have to tell the value of alpha, skin depth, electric field and the polarization. You have to tell the value of alpha, skin depth, electric field and polarization. Solve this question. Okay, so we are having this question in which we are having eta is equal to 200 at an angle 30 degree and the magnetic field is given. We have to calculate the value of alpha. So we are having one formula, if you remember, as first of all, before calculating the value, first of all let's see what is given. So here the magnitude of eta is given and the angle of eta is given. Okay, so the angle of eta is 30 degree, right? And the magnitude of magnetic field is given and the beta is given. So the value of beta is also given, which is 1/2. Now I told you one formula in which we calculated the ratio of alpha and beta, which is tan theta eta, isn't it? We calculated this formula. Do you remember this formula? Do you remember this formula? So if I substitute the value here, we will get alpha is equal to beta into tan theta eta, and the value of beta is 1/2 and tan 30 degree is 1/√3. So hence we will get 1/2√3. 1/2√3. Good evening, Rishikesh. How are you? How is your preparing going on? Thank you for joining us in our session. Yes, skin depth. Now we have to find the skin depth. So the skin depth is skin depth as we have calculated in the last question also. Skin depth is delta is equal to 1/alpha, and when we take the inverse of it, we will get 2√3. Okay, so the delta is equal to 2√3 meter, right? Yes. So now we are having the electric field. Now we want to calculate the electric field, and the electric field, the general expression for the electric field in any medium, because it is alpha, so that means alpha is present and beta is present. It means it is a general medium, or you can say the lossy medium. And if it is general medium or lossy medium, the electric field is given by E0 e to the power minus alpha z, and the wave is traveling in the x direction, so you will write x here, and cos of omega t minus beta x, and electric field direction of electric field AE cap. So this is the general form of the electric field in any medium. Now we are having the value of alpha, we are having the value of omega is not given, so in all the options it is in terms of omega only, and beta is there directly given 1/2. So we have to find just two things, two parameters, that is the peak value of electric field and the direction of electric field. So the peak value of electric field you can easily calculate by magnitude of eta. So the magnitude of eta is E0, the angle is also there, so let's write E0 upon H0. So from here we will write this E0 is equal to eta into H0, and the value of eta is 200 at an angle 30 degree, and the H0 is 10, so we will get 2 into 10 to the power 3 at an angle 30 degree. Okay, so this is the value of E0, so we will substitute it here, and before that we will also calculate the direction of electric field, and the direction of electric field is direction of magnetic field cross product with direction of propagation. So the direction of magnetic field is AY, the direction of magnetic field is AY, wave is propagating in x direction, that to positive x direction, because there is a minus sign, so it is positive x direction, so you will get minus AZ. So the direction of electric field is minus AZ, and hence we can write the direct expression of electric field. So the expression of electric field in this question will be 2 into 10 to the power 3 and cos of e to the power minus alpha x also. So 2 into, at an angle 30 degree, e to the power minus alpha x, you can substitute the value of alpha, cos of omega t minus 1 by 2x, and the angle is multiplied here, the angle is already multiplied here, and a z cap with minus sign, minus a z cap. So it is, and it is in kilovolt per meter. Remember that there is a 10 raised to power 3. So if there is a 10 raised to power 3, that is in kilovolt per meter. So now you are having minus 2 e to the power minus alpha x and cos of omega t minus 1 by 2x plus pi by 6, because 30 degree, the angle is multiplied here, so it will get added with the phase. So this is plus pi by 6 and the minus sign we have taken in the front. So this is kilovolt per meter. So this would be the answer. Yes, this would be the answer, isn't it? So kilovolt per meter minus 2 e to the power minus 6. Yes, option C is there. Gaurav, correct. Hello Tanisha, welcome. So we are solving the question. So if you have studied this part of the EMT, so you can also join us to solve these questions that we are solving or discussing now. So what is the direction of wave polarization? 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 Wave polarization. Gaurav, I am asking about the direction of wave polarization. Wave polarization, I have written that statement. I asked you to note that particular point whenever it is asked about the polarization of wave. So wave is always polarized in the direction of electric field. Wave is always polarized in the direction of electric field, not in the direction of wave propagation. Wave is propagating in x direction, but the direction of polarization is calculated by the direction of electric field. So the electric field direction is minus az, so the wave would be polarized in the negative z direction, not negative y, Rishika. Okay, so again note this point, wave polarization is calculated from direction of electric field. Okay, it is calculated from the direction of electric field, and the direction of electric field we have calculated as minus z. So that is why wave would be polarized in negative z direction. Did you get it? Yes, Rishikesh. Electric field direction. Yes, Hemant. Okay, Rishika. Good. Yes, Sachin. So weightage of EMT. Okay, so let's discuss something different from the topic. Weightage of EMT, EC. For EC students, so we are having the chapters like plane wave, okay, transmission line and wave guide and this antenna. Okay, and in the transmission line, actually I should write in the transmission line we are having the two more chapters, and let's write it optical fiber also. So let me discuss with you about some weightage of the course, because you guys should be aware that how much important this subject is, and the questions coming from these chapters are very easy nowadays. They are asking very simple questions, so you cannot leave this subject. Okay, so this is weightage. Okay, weightage. So in the plane wave we are having two more concepts, that is the polarization. Okay, and in transmission line we are having two more concepts like S parameter and Smith chart. Okay, so you cannot leave these two topics from this transmission line. And in waveguide we have to study now a rectangular waveguide and a circular waveguide. Okay, and in antenna we should study antenna array, etc. Okay, antenna array and the parameters. Okay, parameters like directivity, etc. It is not mentioned, but you have to study that, because else what they will ask. Okay, so they will definitely ask about the parameters, and that is the aperture efficiency, phase equation, polarization, loss factor, etc., directivity, power gain, etc. Yeah, Rushikesh, you are not able to remember the formula. So see, in the plane wave, definitely the two question will come, and in the transmission line there will be one question. In the circular waveguide there will be definitely one question, and in antenna there will be definitely a one question. Okay, and there in the optical fiber actually it is 0 to 1. That means they may ask the question and they also not. So you can see that this is 2, 3, 4, 5. So this is the minimum. I am saying this is the minimum 5 question will be asked. Minimum 5 question will be asked. Minimum 5 questions. Minimum 5 questions. These are the minimum number of questions that I have written. Generally that is the pattern from the plane wave, because the plane wave has a large topic, has a large chapter and has a very many topics. So that's why they ask questions from the plane wave more. Okay, like they ask you from the normal incidence, polarization, what we are discussing they can ask, and also the more weightage of all these will be for the transmission line also. So there may be a 2 question from the transmission line, because the transmission line is also very vast, and this chapter is also having many topics. So definitely they can ask the 2 question from the transmission line also. Okay. So if I am expecting this two question from this transmission line and plane wave, and the rectangular waveguide and circular waveguide will include only one questions, they definitely they will ask the question this year from the circular waveguide. There is more chance that they will ask the question from the circular waveguide. So you will be having 2 question, 4 question, 5 question and 1 question, 6 questions. So you can say that the 6 question will be coming this year. This year in gate 21, the 6 question will be definitely coming. Yes, the electrostatic and magnetostatics are not important as per the gate exam, but for the ESC and for the other exams like ISRO and other PSUs, these chapters are important, and that is why I cover this electromagnetic and magnetostatic basic portion, which includes the Maxwell equation also, and the previous year questions that has been asked. Accordingly, I select the topics from the electrostatic and magnetostatic and then discuss those topics only. So that is my strategy to prepare the subject EMT in the short way. If you want to have a very good command, if you want to have very good knowledge, and if you want to have some practical aspect also, so then for that you have to keep more time for this subject. But in the month of October and November we cannot study in that much depth, and that is not sufficient for that is not required for any exam. Okay, so we should always look for the exam, because we are actually preparing for exam. So this GATE exam is not something about the knowledge of the subject in depth. That is the exam oriented you are preparing, then you should be able to solve the concept and also stick with the basic concepts. Then only you will be able to solve the questions thoroughly. That is important, because in that 3 hours you are not going to check for your knowledge of practical of any subject. Okay, so that will give you just a feel of that subject, but that will not give you marks in that subject. Okay, if somebody is telling about the practical aspect, that the water droplets are measured by the exponential random variable or something else, where these electromagnetic waves are used. So if they are telling about these things, you will get the feel of the subject, but you will not be able to solve the numerical of that subject, because they will not ask you about how the things, exponential random variable or anything will be applied in the real life. They will not ask you this type of questions. Okay, because this is a general exam, this is a basic test exam, this is your aptitude exam. Okay, you know, graduate aptitude exam, it is there, GATE is. So they will not ask you in that much depth. Coordinate systems are also not important, that is just a part of knowing the variables in different coordinate system. Okay, so these are the topics which you should cover for exam. And as I have told you before also, the knowledge of any subject is different, and the getting marks in the subject in the exam is different. In the exams like CAT or something which is for the MBA, CAT, XLRI, etc., they ask you to for the vocabulary, right? There are many questions from the vocabulary section, but did you use that particular vocabulary in real life? So very few of us use that vocabulary in our real life. So, but we have to remember those vocabularies, those words. Okay, so that is like what we use in practice, and in the real life is not for the exam. Exam is something different. For exam, the strategy is different, the planning would be different, the way for clearing the exam, the approach should be different. So in the today's world, because there are a lot of competition going on between the different institutes, like different institutes are there. I will not say the name of all the institutes, but you know that because there are many different institutes, all are just showing their knowledge in the platform, in the YouTube platform. All are showing their knowledge, that they are going to tell you that how much they have knowledge, but are they able to provide you that knowledge, or are you able to make you solve the problems? That is important. If I am having the knowledge, if I am having the MTech degree in the signal processing, if I am having the good command over the speech processing and the video signal processing, if I will tell you something about how the target is detected using the radar signal processing, what will happen? What will happen if I tell about these things? Okay, what will happen? There is nothing, just I will show my knowledge that I am having the good command over these subjects and these topics. I have done the research, I have published the papers. So these are my research area which I have done in my MTech. I have the different kind of knowledge in the signal processing, but I cannot give you that knowledge, because that is not going to help you in exam. But in the different places, these all things are going on. They will show you the knowledge and to make you feel of the subject, but at the end you will not be able to solve the question and you will not be clearing the exam, so you will be at the same place where you are now. So that is of no use for now. Oh, Gaurav, that's very nice that you are pursuing your MTech from BITS Pilani. That is a good college. You should focus on that MTech. I have many students, those who have done MTech from the BITS Pilani, and they have got the very good offer from the different MNCs, and that is to core companies. And if why means I want to know if why you are preparing for the GATE exam again if you are already doing the MTech from the place like BITS Pilani, and I think your branch would also be good. So but still if you are preparing, then I don't know, you should be focused on one thing. If you are preparing for MTech, then you should prepare for GATE, and if you want to pursue MTech, then you should focus on the doing MTech and doing the research. Yes, Vinit, circular waveguide will be covered. Let me give some, let me take some time, okay? Okay, Gaurav, that's good. If you are just you enjoy the EMT and communication, that is good that you are coming here and solving the problems also and giving the reply. But I will suggest, if you personally ask me, you enjoy these things, that is very, very good. But I will suggest that try to involve more in your MTech, because the more and more you involve in the MTech, your thought process will change. You will be having the very good command over your MTech subjects, and that will help you to get placed in very good MNCs. Yes, very nice, Gaurav, to hear that you are also doing the MTech in the signal processing. Definitely you will be knowing that your seniors have got very good placement in the core companies, right? Magnetostatic and electrostatic topics are not that important. If so, we see the main. Yes, uh, Triveni, yes, you can do. You can follow the main channel for the electrostatic and magnetostatic if you want to have some basic idea about those chapters. Okay. So let's start with the new topic, that is our Poynting theorem. Okay, let's start with the new topic, that is Poynting theorem, and we will be solving the another question number 11 after discussion of the Poynting theorem. Okay. So to derive the Poynting theorem, we will be using the Maxwell equation. So everything starts from the Maxwell equation when we talk about the plane wave. So everything starts with the Maxwell equation. Whenever we talk about some fields, all will start with the Maxwell equation. So the Maxwell equation we are having, this Maxwell equation is curl of E is equal to minus del B upon del T, and we can also write it as minus mu del H upon del T. Okay, so this is the first Maxwell equation which we use, and the second Maxwell equation which we use for derivation of the Poynting theorem is curl of H is equal to JC plus JD, and this is sigma into E plus epsilon into del E upon del T, because JD is del D upon del T and D is equal to epsilon E. So sigma E plus epsilon del E upon del T. Okay. So now if I take dot product, okay, if I take dot product of E, dot product of H in this equation number 1 and E in the equation number 2, okay. So let's take the dot product of H in equation number 1, we will get this. Okay, we are taking the dot product of H both the side. This is magnetic field. Okay, this is magnetic field. We are taking the dot product of H both the sides. So what we will get? So this is minus mu H dot del H upon del T. Okay. Now this can also be written as minus 1 by 2 del mu H square upon, you can write the mu outside also, you can write this like minus mu 1 upon 2 del H square upon del T square. Is it clear? Because when the dot product is take place, generally we take the dot product between the two vectors. So the vector here is H and here also it is H. So if you take the dot product and the dot is the scalar product, so it will become scalar value. So this H square is only the magnitude term, and when you differentiate it, you will get 2 into del H upon del T, and to compensate these two we have to divide it by 2. So this term can be written as del H square upon del T square, not del T square, only del T. Okay, this can be written as del H square upon del T. Now similarly, if I take the dot product of E both the side of equation number 2, we will get E dot curl of H is equal to sigma into E square plus epsilon into epsilon by 2 in fact, and del E square by del T, like in the first equation we did. One more suggestion, Gaikwad, yes, suggest some book for communication gate questions comes from that book. How many attempts suitable for us in gate exam? Okay. So Chetan, you are asking about the book of communication. So I would suggest, if you are looking for the questions as per the gate exam, you should follow the PROKIS. The direct question has come from this book, PROKIS. And another good book is BP Lati. The problem you should solve from the BP Lati. There is another book like Simon Hakin, and one problem of Simon Hakin has been previously asked in GATE, but it is not that much book, so give it least priority. That much the questions are not that much in the practice which can be asked in GATE, so this is least priority out of these three. Okay, out of these three, rest is you have to follow the test series, different test series. Okay, you have to follow just different test series, and materials from all institutes like GATE Academy, materials from all institute possible, okay, and definitely practice previous year. Okay, so the previous year questions that you have to follow for the GATE. I know that you will ask about the random variable and random process, and there is no such good book for the random variable and random process, not a single book, but yes, one book is there which is whose name is Oliver. Oliver is a good book, and it is having good number of problems on random variable and random process to practice the basic questions. Okay, so these all are the books that you have to follow for the communication system. So now you can see that there are lot of material and lot of books are there, so that is why the communication system subject has become tough. But if you will approach properly, or if you will follow any one mentor, then definitely you will have very good knowledge or good command over this subject also. You don't need to solve all the questions. There is no need to solve the questions. If the 6 questions are coming in GATE, there is no need to solve all the 6 questions from the GATE. If you will solve 5 questions, that would also be enough, because the easy subjects like network, digital, control systems, in these subjects you can solve all the questions. So there may be some relaxation in these subjects like communication, okay, because every year one tough question will be asked from the communication, and that will definitely give you tension in the exam. So in the exam you are going to leave it only, whether even if you will solve the very tough question in the in your preparation, during preparation, not everybody can solve the tough question in the exam. You will be able to solve the tough question in the exam only when you are having very good sound in all other subjects, because when you start solving the question in the exam, when you will be able to solve all the questions, then you will have some confidence to solve some tough question also. But if you will not be able to solve the question from the other subject, then definitely the tough question from any subject will bother you. Yes, so how many attempts should be there, you are asking, Kumar. So I will suggest to give at least 2 attempts. Give at least 2 attempts, that would be enough. That is your final year, and you should take only 1 year drop, and after that you should think about MTech, because you guys will think that you guys are thinking that the MTech is not good, but if you will go to the MTech, and if you will find when you will find many opportunities after MTech also. If you do your MTech very sincerely, you will be having very good opportunity after MTech. But because of the this like you think that the MTech is only for the teaching, so because of this mentality you guys don't pursue the MTech, and can't see that opportunity which you are going to get after MTech. Yes, so we were discussing about the Poynting theorem, so let's complete it today. Okay. Now we are having one vector identity. What is that vector identity? What is that vector identity? The vector identity which we have discussed is cross product of 2 vectors, divergence of cross product of 2 vectors, that is del dot A cross B using cap back rule. Using cap back rule, I am applying it directly because we have already discussed it in our del operator topic lecture. Okay, the lecture in which we discussed about the del operator, that is lecture number 2, we have discussed this vector identity and how to write it. Okay, so this is cab minus back Okay, so this is the vector identity which we are going to use, where we will take this A is equal to electric field and the vector B is equal to magnetic field. The 2 vectors should be there, and here we are having the 2 vectors, electric field and magnetic field. Okay, so we are having these 2 vectors. Now this is divergence of A cross B, that means E cross H, equal to B means H dot cross product with electric field minus A means E dot cross product with magnetic field. Okay, so when we substitute these 2 values from these 2 equations, what we will get? The divergence of E cross H equal to H dot del cross E from equation number this 3. Suppose this is mu naught by 2 with minus sign, and del H square upon del T, and it is minus sigma E square, because this is a minus sign and here the both are positive, so it will become negative, minus epsilon by 2 and del E square upon del T. Okay. So now if I rearrange it, we will get minus sigma E square and we will get this minus del upon del T and 1 by 2 epsilon E square. Okay. And this minus del upon del T 1 by 2 mu H square, and it is divergence of E cross H. Okay. So now if we take the surface integration both the side, or in fact the volume integration both the side, okay, so let's take the volume integration both the side. What we will get? Volume integration both the side. Okay. So taking volume integration both the side, integration over the volume, divergence of E cross H equal to minus integration over the volume sigma E square into dV and minus del upon del T integration over the volume 1 by 2 epsilon E square dV and the last term minus del upon del T integration over the volume 1 by 2 mu H square dV. So after taking this volume integration, this will become your Poynting theorem statement. This is nothing but the statement of Poynting theorem. So this is the statement of Poynting theorem. It says that total power leaving the volume, this is nothing but total power. So total power leaving the volume, total power leaving the volume is sum of ohmic power dissipated, and rate of decrease in energy stored in electric field. This is called energy stored in electric field. Del upon del T denotes rate and the minus sign denotes the decrease. So decrease in rate of energy stored in electric field, or you can say the rate of decrease in energy stored in electric field. Similarly, it is called rate of decrease in energy stored in magnetic field. Rate of decrease in energy stored in magnetic field. So in this way we define the Poynting theorem. Poynting theorem states that total power leaving the volume is equal to the sum of ohmic power dissipated and the rate of decrease in energy stored in electric field and magnetic field both. Okay. So this is the statement. Yes, so all of you, those who came late, like the videos. Okay, like the video and share the video with your friend. So make it 50 like at least right now. So it is now 40 likes, so we should make it 50 likes. So all of you like this video and share with your friends to come and join the session and take the maximum advantage of this session. Those who came late, may I know why you guys came late in the session? Those who came late, because previously we were having only 20-25 students, now we are having 44-45 students watching live. So may I know all the students, those who came late, what is the reason you guys came late in the live session? May I know? Come on, and everyone should like, because we are having 43 students live and we are having only 41 likes, so it should be at least 45 likes. So please like the video, like this session. So now, if we apply the divergence theorem here, because divergence theorem gives the relationship between the volume and the closed surface. So from the divergence theorem, we know that integration over the closed surface of any vector A dot ds is equal to integration over the volume divergence of that vector, say A, and dv. If we compare the right hand side of the divergence theorem with the left hand side of this Poynting theorem, we can see that this is del dot E cross H. So if it is compared with this divergence theorem, this A will be replaced by E cross H. So it is integration over the closed surface E cross H dot ds, okay, is equal to the whole term, which is minus sigma E square dv and minus del upon del t integration over the volume 1 by 2 epsilon E square dv, and also minus del upon del t integration over the volume 1 by 2 mu h square del v. Okay, so this is the statement of the again Poynting theorem. Okay, so it is nothing but a total power passing through the closed surface also. We can also say like this: total power passing through the closed surface is equal to the sum of ohmic power dissipated, rate of decrease in the energy stored in electric field and magnetic field. Okay, so actually we are saying it as power. Okay, the left hand side we are saying as power, but the right hand side you are thinking that this is energy. So this is the energy which is written inside the integration, and because of the time, energy per unit time will give you power. So because of the differentiation we are having the power. So actually it is a power, but it is, we are saying like rate of decrease or rate of energy stored in the electric field. So rate of energy stored in the electric field means become power. Thank you, Kumar. Thank you for giving so much effort. Yes, random. What you want to say? So now here we are having one term which is called Poynting vector. Because we are discussing the Poynting theorem, we are having a Poynting vector. Okay, so this Poynting vector, what is that Poynting vector? So the Poynting vector is denoted by vector P and it is equal to E cross H. We have got this term E cross H. This E cross H, because this is the cross product of the two vectors, which gives you another vector, and it is nothing but a Poynting vector. So suppose the wave is traveling in, suppose wave is traveling in positive z direction with electric field with electric field, okay, with electric field E is equal to E naught e to the power minus alpha z cos of omega t minus beta z, and let us say the direction of electric field is x. We are assuming that the direction of electric field is x. So accordingly we can write the magnetic field also, and H naught is equal to e to the power minus alpha z and cos of omega t minus beta z ay. Okay, it will become ay. How? So we can write the direction of magnetic field from this expression. The direction of magnetic field is the direction of propagation cross product with direction of electric field. Direction of propagation is z, direction of electric field we have assumed x, so it will be ay. So that is why we have written the direction of magnetic field as y. But the peak value of magnetic field can also be calculated by E naught and divided by eta at an angle theta eta. In any medium we are saying, we are calculating it for a general medium. For any medium you can apply this. Okay, so e to the power minus alpha z cos of omega t minus beta z ay cap. So when we solve it, we will get E naught divided by magnitude of eta e to the power minus alpha z and cos of omega t minus beta z minus theta eta ay cap. So this is the H and this is E. So for this particular assumption where the wave is traveling in the positive z direction with electric field x component and magnetic field y component, we will be having the Poynting vector. So this Poynting vector we have to calculate. So now we will calculate this Poynting vector P, which is the cross product of these two, and the cross product, that means the multiplication of these two equations. Okay, so you have to multiply these two and take the cross product of vector. So when you multiply this E naught and E naught become E naught square divided by magnitude of eta, and e to the power minus alpha z and minus alpha z become e to the power minus 2 alpha z. First is omega t minus beta z, second one is omega t minus beta z minus theta eta, and ax cross ay. What is this ax cross ay? That will become az. Okay, that will become az. So the direction of propagation is z. This is what we get. Okay, now we have to calculate the time average Poynting vector. Okay, this is the Poynting vector, but we are more interested in the time average Poynting vector. Time average Poynting vector. Poynting vector is basically a power density also. It is a power density. Okay, Poynting vector is power density, which will give you power per unit area. Okay, Poynting vector is nothing but a power density. It will give you power per unit area. So we want to calculate the time average Poynting vector. So how do you calculate the time average Poynting vector? So the average value of the Poynting vector is calculated by 1 upon time period integration over the time period vector p dot dt, vector p into dt. So 1 upon t integration over the time period, p we have written here. So the vector p we have written here, which is E naught square upon magnitude of eta and e to the power minus 2 alpha z cos of omega t minus beta z and cos of omega t minus beta z minus theta eta into az. So here we can apply the formula of 2 cos A cos B, and we can separate it into two parts, which is 1 upon T integration over the time period. It is E naught square divided by magnitude of eta and e to the power minus 2 alpha z. When we apply the cos A cos B formula, it will become cos A minus B. So when we calculate cos A minus B, it will become cos theta eta, and Az will be there, plus 1 upon time period integration over the time period. This is E naught square upon magnitude of eta, and yes, 2 cos A cos B we have applied, so 2 will also be there in the denominator. Okay, so this 2 will also be there in the denominator because we have applied the formula of 2 cos A cos B, which is giving you cos A minus B plus cos A plus B. So now A plus B, when you will perform, you will get 2 omega t minus 2 beta z minus theta eta, and this is dt and Az cap, and here also we will be having dt because we are going to integrate with respect to time, right? Now because this is nothing but the average value of the cosine, so the average value of cosine is 0 over the complete time period. Okay, the average value of the sine or cosine is 0, so the second term will be 0, and the first term will be, first term is here E naught square upon 2 eta, which is common, 2 into magnitude of eta, and e to the power minus 2 alpha z cos theta eta is also common, and it will become 1 upon t integration over the time period and dt, and also here we are having Az. Okay, so cos theta eta into Az. Now when you perform the integration, this is the integration over the time period t, that means 0 to t. So finally this time average Poynting vector you will get. Finally this time average Poynting vector you will get for any medium E naught square upon 2 into magnitude of eta e to the power minus 2 alpha z and cos of theta eta and Az cap. Okay, so this is the time average Poynting vector. This is the time average Poynting vector. Okay, this is the time average Poynting vector, and as you can see that we have assumed that wave is propagating in the z direction, you are getting the result in the z direction. The Poynting vector, the average value of the Poynting vector you are getting in the z direction because the wave was traveling in the z direction. It means that the flow of power in the electromagnetic wave is in the direction of propagation. So the propagation of the power is in the direction of propagation of wave. Okay, so in general you can write it as AK. You can write the direction of propagation directly in general. This is now the general result. According to the direction of propagation, you can write the unit vector here. If the direction of propagation is minus x, you have to write minus ax cap. If the direction of propagation is plus y, you have to write plus ay. Okay. Now for lossless medium, let's calculate it for lossless medium, because this is for the general medium, in general medium, right? This is in general medium, and for lossless medium, you know that the alpha is 0 and theta eta is also 0. When the alpha is 0 and theta eta is 0, this time average Poynting vector will become, E naught square upon 2 times of magnitude of eta and the direction of propagation for lossless medium. E naught square upon 2 times of magnitude of eta and direction of propagation. This is for lossless medium. And remember that the unit of this time average Poynting vector, because I said this is the power density, it is watt per meter square. Power per unit area, that means watt per meter square. So once you get the time average Poynting vector, okay, once you get the time average Poynting vector, you can also calculate the power radiated. And the power radiated, or simply power, you can calculate. This is nothing but how much power is passing through any surface. Sometimes the wave will travel through some surface. When the wave will travel, it will cross the surface, and when it will cross any surface, how much power crossing through that surface, that you should calculate. Sometimes that will be required to calculate how much power is actually passing through any surface. So when the wave will travel through any surface, how much power is actually traveling, passing. So the power is integration over the surface power radiated dot ds. Okay, so this is the power passing through any surface. Power passing through any surface, passing through any area. If you want to calculate the power, and if you are having the time average Poynting vector, if you are having the time average Poynting vector and you want to calculate the power, so this time average Poynting vector will be calculated from either this equation or this equation depending on the medium, and take the dot product with the surface by which you want to calculate the power, okay, and you will get the power. And also sometimes for a complex field, the time average Poynting vector is given by 1/2 real part of electric field cross product with complex conjugate of magnetic field. Sometimes if the field is complex in nature, if fields are complex in nature, fields like electric field and magnetic field are complex. If fields are complex, okay, if fields are complex, in that case you can calculate the time average Poynting vector by 1/2 real part of E cross H complex conjugate. Yes, Prem, you need to practice more and more questions from the previous year. Okay, you need to practice more and more questions. That is the only solution of getting the command, because you are able to solve the questions when somebody solve the questions, right? Like if I solve the question, you will be able to understand this. That means you are able to understand the concept. So you know the concept, but you are not able to apply the concepts in the questions, and that will come when you practice more and more questions. Okay, so that is a very good part, that you are able to solve the questions when I solve the questions, and That is very good that you are trying by yourself. So Prem, you are working hard, and that is very nice to hear that. Okay, so all of you, so out of this 50 user, I would like to know how many of you are English user. Okay, how many of you are English user? So tell me once, Saurabh, yes. Oh, just I switched off the mic for time being. Oh, now I think yes, Hemant, Saurabh, you are not. Okay, Hemant, you are English user, that I know. Okay, fine. Out of 48 students, if the more than 40 or 30 students are English user, then it would be fine that you are coming here and watching this video, right? Yes, Lakshmi, I know about Lakshmi, Hemant, and Anju. Okay, so those who are joining the session from the beginning, that I know. Those who came late, out of those students who came late, who joined after 1 hour, then they can tell me if they are English user or Hindi user, because those who came late in the session, why they came late, that I wanted to know. But nobody is replying that. I would like to ask you that why you guys are coming late. Just tell me that why you guys are coming late. Please let me know why you guys are coming late. Yes, Rishika. Yes, Rishika also. She also joined from the beginning. So Rishika, I know about you. But those who came later, I would like to know about them, that why they came late, why they are not attending the sessions, and why they are attending the session in the middle, and are they able to understand the topics or not. That is important for me. If I am delivering anything to you, then it is important for me that to know about you. If I know about you, I will be more I will be able to inculcate the technical things in the youth. So that's why I am trying to interacting with you all. If you will give me proper response, I will also give you the better concepts and in better way, so that you will be able to understand the things very nicely. Okay, I think nobody is interested. So guys who joined from the beginning, so we will meet tomorrow at the same time 5 p.m. and we will be solving the questions from the Poynting vector and also starting with the normal incidence. Okay, so we will be discussing about the reflection coefficient, transmission coefficient, how much part is reflected, how much part is transmitted. We will be discussing tomorrow at 5 p.m. Thank you. Good night.